Okay, let's do a quick. Let's do another problem here on this list. Partition labels. You're given a string S. We want to partition the string into many parts as possible so that each letter appears in at most one part. For example, the string ABA can be partitioned into ABAB or CC. Wait, what? We want to partition the string into many parts as possible so that each letter appears in at most one part. Okay. But partitions such as okay. But partitions such as ABA and BCC or AB are invalid. So that after concatenating all the parts in order, the resultant should be the string. Okay, so I have to keep the order of the elements. Return a list of integers representing the size of each part. Okay. 10, just the single string itself. Interesting. Okay. So you're given a string S where we want to partition the string into as many parts as possible so that each letter in at most one part appears in at most one part. Okay. This is a little bit confusing on what they mean by okay, so here is ABA, BC, ABA. Okay, wait. So probably some account like frequency list, right? Kind of take very greedy, so take as many characters as you can until you break until something gets violated. Once we create the part, break, take length, append, take length, and append to list. Return output. Now, what does it mean? What does it mean to what does it mean to something that what is that rule? I guess we have let's use a simpler example. So the output for this AB right here, the output here is ABA BCC, right? And then the return is force 2 because it's transformed into ABA BCC, right? This is kind of the thought process here. Right, this is the thought process here, guys. Right. So we could break into parts. I know how it works, but now how do I do this part? Well, we need to figure out why this is a part in itself. Well, I'm not sure why. Let's see. For example, the string ABAB appears in at most one part. What does that mean by at most? Like, so like, oh, okay. Okay, I see what they mean now. I see. Okay. That means they're saying that the letters A and B will only appear in one element in this kind of list. Okay. Right? So that means okay. So this is wrong because B appears in two of the lists. Right. Okay. 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 I see the thing now. So we should definitely have a frequency list, right? Right? Where, or frequency dictionary, right? Where we want to take as many characters as we can, and as soon as all of the frequency in this, like, we'll create this global, we'll create this frequency as soon as the letters that we have created are all been used, like our current, I guess, window per se, or partition, then that is a partition we should do. Like, I think at a certain point, this will be the last one because we'll detect that all the letters in our window are used up. So maybe I'll create like a set of all the characters. Right? Like, I can calculate all the A's, I can calculate all the B's, I can calculate all this, right? So in this case, we'll say A is, I think, 2, B is 2, and C is 2, right? So we'll create our first, part will be A, so we take away 1 here. B, take away 1 here. A again, take away 1 here. Right. I put A here. Then add B, or take away B. And then right now, all the characters are all 0. Yeah, all the characters are all 0. So that is a part. So I might have to create another frequency, which is the frequency of, not a frequency, but like all the characters we have. Let's see if this is okay, relatively small actually. Okay, I think this works. Then I can create like a set, and I can just check, is your current part like as soon as we find that all of them are 0, boom. Like all the letters are in the 0, and maybe like if I try to add C, then that would just ruin the thing, right? I think that's the intuition here. That this kind of looks like a. I think this works. I don't know what could I else do here. Like I'm trying to figure out like how one gets like broken, right? So maybe do I check if C is could I try to add C? But the thing is, if I do it that way, then I should just take the whole string. No, I think it's possible. I think that's the best way. Have a detection algorithm that kind of checks if this thing is you know, a detection algorithm that checks for the thing right there. So like a helper that will check if the current string is yeah, so we'll do this. So okay, res here, return res for every character in S. Definitely need a counter for sure. Okay, so we have this stuff here. Okay, so for every character in S, do that. Yep. So for every character in S, okay, I guess current like part is right. Part dot append character. But I guess we have to do while not 0. Okay, no. While I feel like I need the index actually. Let's do this. So for every I in S, enumerate S if character res of character. Okay, so hold on. Part while. Actually, I actually need to do this instead. Let's do I while less than length of s. Well, first off, it's gonna be jumping like wherever we can. So part equals here. While j is less than length of s, j equals I. If for every character in part, if character for every character in part, if character so if the character, so we'll check up the lookup CNT character. Flag false. True. If CNT does not equal 0, flag false. If flag, then take the length of part, right, brother. Res.append that. Then we will say I equals j. Or the next letter. So let's see if my algorithm makes sense here. So we go through every letter. So A, B, so let's do the simpler one. We put in A. So we'll actually create the list. Start at 0, while 0 is less than length of s, flag equals true. For every character in part, there's nothing, so we'll absolutely skip this. Well, yeah, let's probably part.append character, which is s of I. Yeah, s of I, not s of j. Let's do s of j. So we put that in for every character. Oh, yep. Then we do s of I, c and t of that character, decremented down. So we put in A, right? So we'll put in, so we put in A for every character. If that doesn't equal 0, well, the first character in there, it does not equal 0, so we put it to false. So we keep going, we increment. Now we go to B. B is in there, b.append. So put B. Then C and T is of I minus equal 1. So yeah, still not done. So we do flag equals true for every character in part. So A, B, still it's like, I think it's like 1 and 1. And put it to false. Skip that, go to the next letter. We'll go to another A. That was the last A. So first one doesn't trigger this. A doesn't trigger it, but B does trigger it because B still a frequency 1, so we put the flag. Please put that. Then we add B. Now everything in there. So if flag res the append length of part, boom, we're done. Okay. Res the append. And then break. Then we say J plus 1. No. Let me see. Print part. A, B. That's exactly what I didn't want. We need to clear it. Uh-oh. That's way too common. If every single one of the part is 0, then that's a potential string. Yeah, so if that's a potential part to add. So CNT character does not equal that. What am I doing wrong here? For every character in part. I think I know why. It's because of this shit. Yeah. Yep. That looks like it works. Yes, awesome. Very simple problem. All right, see you guys tomorrow.